All right.
And then share the screen. I've got 5E today, and then I want to do the support for 6A. So if you ain't got support, it'll help you out still for the 6A stuff. Okay? All right, so 5E, we're going to look at correlation. So correlation. And compounding. So correlation. And really, y'all remember what the scatter plot? Like it might have, I might do a scatter plot of how tall people are versus their weight. I put all the dots on and everything. So that's the scatter plot. So y'all, correlation is this between two variables with higher values of one variable consistent with higher values of another variable. Go with higher values of another variable. Or when higher values of one variable consistently go with lower variables of another variable. So, or when higher values of one variable consistently go with lower values of another variable. So let me show you sort of what to talk about on that. So, let's see. I can go by something like diamond weight. And over here, I might say the value in dollars. And I'm just going to sort of sketch here. I don't know what diamond weight. Oh, so I might do what? 4 carat, a half carat, 3/4 of a carat, and then a 1 carat diamond. And I'm just going to ballpark figures. $250, that's for $500, $750, and $1,000. I'm just using some dots on there just to give you an idea. But it's true usually, right, that the more carats the diamond is, the higher that price is going to be, right? So that's what they mean by good correlation. As the size of the diamond gets higher, the price of the diamond is going to get higher. As the size of the gas tank gets bigger, the price to fill that gas tank is going to get larger, right? So those are both increasing together, okay? A really, really, really good correlation almost makes a straight line up through here, okay? But you might have data scattered everywhere on here. But a good correlation is still going to semi look like a line going through there when you average it all out. I won't be grabbing it. Maybe when y'all look at the graph, and if you think it's a good correlation. Okay? The more it looks like a line, the stronger the correlation. Okay, you get a lot of data scattered everywhere. Then I might not have a correlation that says that one gets larger, the other one gets larger. Okay. So a bad correlation. Well, I'm gonna start throwing some dots here. This one has more of a line shape going through it, to where this one, I really couldn't say that, could I? Because these values over here, as it's getting larger, well, I got one large, but yet one small. So there's not really a correlation that tells me as this one goes up, is my Y value going up also. Okay? So let's look at some examples of correlation. So some examples of these could be, there's a correlation between the variable height and weight of people. So there is a correlation between the variables of height and weight of a person. And that is, for the most part, it's true that taller people, on average, weigh more than shorter people, right? There's a correlation between the variables. So there is a correlation between the variables demand for apples and price of apples. So if I have my price going along, it's usually true that as the price increases for apples, the demand will probably go down because they're paying a lot more for these apples. Okay? If the apples were going down in price, then you would expect the demand to increase on those. Okay? And then another one I had, there's a correlation between practice time and skill for piano players. Right? It would make sense that if you practice more, then your skills going to go up. So the longer you practice, we would expect the skills on that piano to increase also, okay? And really, that's what it, correlation to me is just the relationship between the two. Okay. All right, so let me talk about the scatter plot.
Your screen is freezing.
Oh, okay. Every time it does that, let me reshare with y'all. We're pretty bad about the freezing, man. Alright, so scatter plot is a graph in which each point represents the values of two variables. So a graph in which each point represents on the first one. So represents the values of two variables. I'll go with the diamond blade versus the diamond. I was looking at data based on the two. All right, so we'll look at, based on scatter plots, we'll look at relationships between two data variables. So there can be no correlation. That means there is no apparent relationship between the two variables. So no apparent relationship between the two variables. Okay, so you just have scatter dots everywhere, but it don't have that line shape to it, okay? So I can't determine if one's increasing, is the other increasing with it or decreasing. There's not a pattern to it, okay? So we say that has no correlation. Positive correlation would mean that both of the variables tend to increase together. Except y'all could look at for some possible correlations. It seems to me like when we got Democratic presidents, our gas goes up. It's already went up with like 25, 30, 40 cents since we had Biden in there. And usually you'll see on the Republican, the gas might seem to go down a bit. That'd be something you can play with and see. There you go, negative correlation. That means as one of my variables increases, the other one is decreasing. So one variable increases while the other decreases. So those are my correlations. Now the strength of a correlation. So the more closely two variables follow the general trend, the stronger the correlation. So the more closely two variables follow the general trend, the stronger the correlation. In a perfect correlation, all data points lie on the straight line. Okay, so that's what was shown you earlier when I did that with the diamond. As one went up, the other went up, and it pretty much looked like a line through there, okay? So the stronger, the more line it looks. If there's not no correlation, you're just going to have points scattered everywhere, okay? As one goes up, you can't tell if one's going up or down or nothing, okay? So I'm going to pull a picture of some up here on the back so that you can see the picture of a positive correlation, and then I got one with a negative correlation. So let me pull this up. I'm going to quit sharing and go to a different screen for y'all. So y'all see how that positive correlation is sort of, you got a few what we call outliers, but the general trend is as this is going up into place, the factor in dimes is going up, right? And that's what I had right here. Both variables tended to increase. We had a negative correlation, whereas one increased, the other decreased. So look, as these life expectancies increase, the infant mortality rate is decreasing. Which makes that a negative correlation. They're all on mute, must be out of here. All right, so that's correlation. So let's get y'all on 6A support stuff. So if y'all ever messed with mean, median, and mode, that sounds familiar, right? I'm going to look at this just support for 6A, and I'm going to do the problem finding the mean, median, and the mode, okay? So this will be support for 6A. Now that 5B, they're just going to ask questions. You just answer the questions on that. So No math in that. 6A will have some math. Okay? So, what is the mean here? So the mean in our terminology would be the average. Okay, so the average of all data or value. So y'all have ever averaged your test, added all your tests together, divided by how many you had. Y'all found the mean or the average. Okay. So to find the mean, we add up all the values. So we add all values. And then divide by how many we have. So you add up all your values and then divide by how many you had. So if you had 5 tests, you would add up all your scores and divide by 5. Okay. The median. Y'all heard of that? Y'all heard of it? Have y'all heard on the road the median is that middle stuff, right? So it's the ones in the middle. So it's the middle value. Now there's 2 ways you can find the median. If it's an odd number of data, so if an odd number of data, so if I had 7 data points, I'm going to pick the one right in the middle, which would be what my third. Okay, so pick the middle number. Now we'll say this: when I find my median, I put these things in order from small to large or large to small. Okay, that way when you got them in order, you can actually find that middle number. If it's an odd number of data, I mean not odd, but even. So if it's an even number of data points, you take the 2 innermost points, add them, and divide by 2. So take the 2 innermost points, or the 2 in the middle. Okay, the 2 innermost points and add together. Then divide by 2. And then let's see. Oh, we got what left? The mode. So the mode is which data point happened the most. So sometimes that mode might be one number that happened, say, 2 or 3 times. You might have 2 numbers that both happen 3 times. Or you might have no repeats on any of those numbers. If you have no repeats, then you have no mode. Okay. And basically, the mean, median, and mode are what we call measures of central tendency. Um, and we get into that a little bit later. So right now, we'll put some actual times recorded when students participated in an experiment. So these are the actual times. So 55, 52, 74, 64, 67, 60, 49, and 49. So first I'm going to find the median. So y'all, to find that median, I'm going to add them 8 scores up and then divide by 8. Okay? So I'll tell you what I'm doing by 8. I'm going to take 55 plus 52 plus 74, 64 plus 67, 60, and then 49 plus 49. I'm going to add all of them up. And then I had what? 1, 2, 3, 4, 5, 6, 8 scores. So I'm going to divide all that by 8. Okay. All right, so here we go. Let's add them up. 55 plus what? 52, 74, 64, 67, what is it, 60, and then with 49 plus. When you add the top, it's 170. Then we're going to divide that by 8. So I get 58.75. So the average of those 8 times was a time of 58.75. Okay. Then we're going to find the median. Oh, that was my mean. I change that to mean. Woo, I get to write stuff different than I thought sometimes. So I'll keep on. So I just found the mean, okay, the average.
I assume you do what you were doing.
No, I get up here. Sometimes I'll say stuff, write different sometimes. But that median in the head. So now I'm going to find median, which is the middle. You know, to find the median, I'm going to put these in numerical order from smallest to the largest. So let's see, the smallest is 49. 49 again. So let's take care of them two. What's next? 52. 55. 60. 64. 67 and 74. So I've got an even number of data points. So when I had an even number, I had to take the 2 innermost numbers. I'm going to add them together and then divide by 2. So I'm going to do 55 plus 60 divided by 2. So that'll give me 115 divided by 2, which gives me a 57.5. So notice the mean gave me an average of 58.75. The median gave me an average of what, 57.5. And then the last one I'm going to do is the mode. So out of them 8 data points, which one happens the most? 49. So they have one twice. It looks like everybody else has just one. So mode would be the 49. So these are 3 different ways you can look at data. The mean is more affected by what we call outliers. So next class, I'm going to talk about outliers. But there's data that don't look like it's fitting my line. It's way higher or it's way low. The mean, if you throw a big number in here, it changes the average pretty high and low. The median, it usually stays fairly the same, but you're still looking at those little numbers on there. So them real big outliers might not take that median and the low much, okay? But it usually, let's take them averages.
So would there be more than one mode or two? Or would there be
So say this 55 was 52, my mode would be 49 and 52. It would be both of them. Okay? Now, if you didn't have no repeat, then you would have no more. Okay. This is not too bad. Just get used to it again, right? All right, so this one I'll do one more. Oh, I have one more. I'm gonna do like 7 tests. So 85, 78. Oh, this makes 92, 85. Oh, I got 54. Then I want one more help out. 80. I wanted an odd number this time. Last time I did an even number when we found that mode stuff and mean. So first we find our mean. So the mean, right this time, right? Mean. I want to add them all together and divide by 1, 2, 3, 4, 5, 7. So I'm going to add them all together, divide by 7. Get all that. Divide by 7. I'll tell you the thing about stats that most people don't like is because sometimes you got a whole lot of data points you're having to find those averages out there. So you get 592 on top, divided by 7. Now, y'all, here's one thing I do know about this problem. My average cannot be below 72, and it cannot be higher than that 98. So those are my low and high scores, right? My average has to be somewhere in between there. So when I take that and divide by 7, I'm getting an 84.57. So not too bad. Them lower grades averaged out, them higher grades, but we still got pretty good seeds sitting there, right? To find my median, I'm going to put all these scores in numerical order. So I got 72, 78. Let's take care of that for the 10. Oh, what's that? 82, 85 twice. And then I got a 92 and a 98. So looking at that data, what is my median or my center? So I had what, about 7 of them, I'm looking at this point right here, 12, which is definitely 85. All right. The mode, what's the mode? Did that 85 happen? 2 times? So 85, 85. So look what this one does. Are these three values not 30 similar together? 85, 85, and hell, 84.57 is going around to 85. So when you got the mean, median, and mode really close, it makes the iron symmetrical bell curve. And we'll learn about these curves and what makes them tell you and all that fun stuff. All right, so some of the questions you'll get on 5E homework. It wants you to define positive correlation. Well, remember, positive correlation was when they both increase together, right? Negative correlation was when one increased and the other one decreased. No correlation meant there was no apparent relationship between the two variables. And then remember, on the strength of correlation.
Are you writing this graphic? What are you writing on the board?
Correlation, the closer they're going to make with a line. And mix up.
We're froze. I can't see.
Getting that, everybody's on mute. Huh.
I can't see anything. Are you writing on the board?
I'm not gonna get into that. It's a main course until next class. So, which don't mean median mode correlations. Strong negative, no correlation, right? The more it looks like a line, though, the stronger that correlation is. Okay? All right, so we keep it in mellow. Y'all got spring break next week. Any of y'all leaving out of town? Where you going? Oh, well, that's still in Arkansas. I know. I had some people, they talk about going to, oh, hell, is it Padre Island or something like that? So, not Padre Island or something they talk about. I watched the news last night. They saw Miami Beach was packed full of people.
I'm still nervous about the hotel thing. I'm not going anywhere until I get back.
I'm double vaccinated with both my Modernas. So,
Yeah.
as soon as y'all get vaccinated, we take these masks off up in here. All right. So these masks, they called me up or
Terrible.
was it last week, Thursday, we didn't have no air in here, remember? Oh my God, my mask was sweating. Now we got the pool. All right, so if you haven't done the projects, y'all gotta get them in. Yeah, just that one sheet.
You said damn, I thought like there was only the one, right?
Right. I'll do another stats project when we come back from spring break. And it'll be doing stuff sort of like this. All right, anything else? So that was 5E, 6A support, okay? So I'll get this video out later and I'll see y'all Thursday. All right, any questions online?
Thank you.
All right, I'll see y'all Thursday.